Number 4. Samples of compound X, Y, and Z are analyzed with results shown here. Okay, so then they give you the 3 different compounds, their descriptions, and their masses of carbon with their masses of hydrogen. And then they say, do these data provide examples of the law of definite proportions, the law of multiple proportions, neither, or both? And then what do these data tell you about compounds X, Y, and Z? Okay. All right, so first things first, we need to know the difference between law of definite proportions and law of multiple proportions. Now, with chemistry, if something is definite, right, it basically will stay the same. So you could think of when you see definite, it will have the same information. So the law of definite proportions just means that the compounds that you make from data will have the same ratio. So definite, same ratio. And when we talk about law of definite proportions or multiple proportions, it will come down to compounds, not single elements. There always has to be a compound. Conversely, the law of multiple proportions is when the compounds will have different whole number ratios. And key in on this whole number ratio idea. So everything will be able to be simplified down to whole numbers. And we know whole numbers from math or maths, right? 1, 2, 3, 4. So it should be able to simple it down to just as easy as 1, 2, 3, 4, etc., etc. So the key is definite proportion, we'll see same ratio numbers. Multiple proportions, we'll see different. And multiple, right, means we have multiple outcomes, which means different. So you can kind of boil these two laws down by just looking at the third word of each. The law of definite proportions, same. The law of multiple proportions, different. All right, so now we just have to find out what the ratios are, right? Because it's going to be either the same ratio or different. So I'm going to just set this up by saying compound X, compound Y, and compound Z. All right, so now we have to make a ratio, right? And remember, when we did our conversions, we did tons of ratios. So in this case, it's going to be the mass of an element. Now here, they give you the 2 elements that are in the compound, right? Carbon and hydrogen. We don't know what carbon, how many carbon or how many hydrogen we have. So it would be kind of like CaHB, right? I don't know how many carbons I have. I don't know how many hydrogens I have, so I just give them as variables. So when we write our ratio, it could be mass of carbon, C, divided by mass of hydrogen. Or if you want to flip-flop it, you can, because remember the ratio, the division sign means equal. So you could put mass of hydrogen on the top over mass of carbon, but you got to keep it consistent. So when we do the ratios for X, Y, and Z, whichever one you pick, you have to keep constant. So I'm going to choose this one, all right? So for each one, I'm going to put the mass of carbon on the top divided by the mass of hydrogen. So let's set them up, and then we'll do the division. So I'm going to say for compound X, it's 1.776 grams of C divided by 0.148 grams of H. For compound Y, it is 1.974 grams of C divided by 0.329 grams of H. Do you see how you have to be consistent? And then for Z, it would be 7.812 grams of carbon over 0.651 grams of H. Let's see what we get. So I'm going to do the first division. I'm going to say 1.776 divided by 0.148, and you get 12, right? Now remember, you could always turn a whole number into a ratio by saying that number over 1. So we'll say 12 over 1, and there's your numerator and denominator. So 12 grams of C equates to 1 gram of H. same thing here. Now, I'm not going to, you know what, we'll keep it, that's fine. The next one, let's do the math. 1.974 divided by 0.329, you get 6. Let's still turn it into a ratio, so it's over 1. Grams of C, grams of H. And then last but not least, 7.812 divided by 0.651. We got 12 again. So 12, turn it into a ratio, over 1. Grams of C, grams of H. Okay, so now we got to know, does this data provide examples of definite proportion, multiple proportions, neither or both? Well, let's look here. This first one was 12 over 1, and the third one, compound Z, was 12 over 1 as well. So that those compounds have the same ratio, and same is definite proportion, law of definite proportions. So compound X and Z are showing, I'm just going to put LODP, law of definite proportions, because they're the same ratio. But now, when you throw in compound Y, you get 6 over 1. Compounds will have different whole number ratios. That's the law of multiple proportions. Because if you took one of these and put them over the other, you would get either 1/2 or 2, right? That's a nice whole number ratio. So we can say compound X and Y show law of multiple proportions because they're different whole number ratios. And the same thing goes for compound, I'm going to put that over here, compound Y and Z, because it's also 12 and 6. So that's also the law of multiple proportions. So we did show law of definite proportions by having the same ratio, and we showed the law of multiple proportions because we had the nice whole numbers, right? You could do compound X over, I just want to show you guys, compound Y, and the number that we got for X was 12, and the number we got for Y was 6. So it comes out to be 2 over 1. That's the nice whole number that I'm talking about, all right? So that's the law of multiple proportions. So it's definitely not neither, and it's definitely not both. So, oh, actually it is both, right? Because we have law of definite proportions and we have multiple proportions. So the answer here shows both. So that's the answer for that part. And now it says, what do these data tell you about compounds X, Y, and Z? Okay. So technically, since X and Z have different ratios than Y, right? X and Z had 12 versus Y had 6. Y is a completely different compound. So I'm just going to say Y is a different compound from X and Z. But now, do we know that X and Z are the same compound, right? X and Z? We know that the ratio is the same, right? But that does not tell us if the compound is the same, because let's look at water, right? I'm going to put it up here. H2O versus, let's do H4O2. Now these ratios is a 2-to-1 ratio. You have 2 hydrogens for every 1 oxygen, right? So this would be 2 over 1 for hydrogen over oxygen. Now here you have 4 hydrogen for every 2 oxygen, so this would be 4 over 2. But what does this boil down to? This can simplify to 2 over 1, because 4 divided by 2 is just 2. And you could turn any number into a ratio by putting it over 1. So look at that. This has the same ratio. But were the compounds the same? No. H2O versus H4O2. So can we say that X and Z are the same compound? No. They have the same ratio, but we are not certain that they are the same compound. So actually, X, Y, and Z may be all different compounds. I'm just going to put comp for compounds. So that's what the data tells you. X, Y, and Z can technically be all different compounds. We know that Y is a different compound because the ratio is different, but we also can't specifically say that X and Z are the same just because they have the same ratio. That does not mean that they have the same compounds. All right? So that's all your answers. This data is both law of definite proportions and law of multiple proportions, and the data just tells us that they could all be all different compounds. All right? So hopefully this helped, guys. If it did, click that subscribe button. We got tons more questions coming your way. Thank you so much for that. That actually helps us out a lot to get the word out to other students that want this type of, content, right? Thank you so much. I appreciate all of you guys. I'll see you guys all in the next lesson. Bye-bye.